Okay. We basically started working on question 6 from the 2016 exam. This was given to you in your review packet, the one with the multiple choice and FRQ questions, right? This was one of the number 6 questions that I posted. I thought this was a good one for a number of reasons. Number one, it was Lin Reg. That tends to be something that we struggle with. Number two, I didn't want to pick one that was just so hard that nobody would get right. So I thought this one, maybe it's a topic we don't really like as much, but definitely still get a lot of the points correct. So there's 2 things we always want to look at. Number one, what's the right answer? What did you get? You know, did you put down what was necessary, right? There's lots of things here that you can put down that you don't get credit for, and you can say things that you think are completely correct, but you'll find out that you left out little elements here and there. So what we want to do is we want to kind of walk through each one of these pieces and go over it. So if you don't have the question in front of you, I highly recommend you get it out, look at the questions as well as your responses. Okay, so question number 1, well, from the first part, I'm going to read the paragraph. I'm going to look at the problem. It talks about a newspaper in Germany reported that the more semester hour credits you take, the more semesters you take, then the higher your average is in your starting job, right? In terms of thousands of euros. That's important because it says 50 there. It's not $50,000. It's 50,000 euros. So make sure that when you describe your units in terms of slope and things, you are using the correct units. It talks about that if I just look at the scatter plot, I can clearly see that there's a positive association with that graph. In part A, it says, does the scatter plot support the newspaper in terms of what it said about the number of semesters and starting salary? Justify your answer. What did you say? Yes. Okay. And why would you say yes? So the question is, I think you are definitely right. It does support the newspaper, and it does that because we can see a positive association in the graph, right? Here's what they said. The scatter plot supports the newspaper report about the number of semesters needed to complete an academic program and the starting salary because it shows a positive association between these 2 variables. In order to get full credit for this, okay, well, before we do that, section 1, they kind of talk about in the key, is the first 2 pieces. So let's go over the next part, and then we'll come back in and talk about what was really needed to get a full mark on this piece. Okay. The next part talks about identify the slope of the line and interpret it in context of the problem. Again, not really a challenge here. What did you say? No. You gave me the line of best fit, although you gave me the, did you say X was associated with 1.15 or the 34? I couldn't remember. So you gave me the correct line, but it didn't ask for the line. Now, I'm not sure if you didn't say specifically what the slope was, right? If you give me the line of best fit and then talk about the slope in the following statement, not a big deal. In fact, you didn't even need to state the slope. If you used it in context of the problem, it's still going to give you credit for it. You have it backwards. It's always for each X, the Y changes by the slope. And you can see that clearly that X is on the X-axis here, and the starting salaries are the response to the number of semesters you've taken. So in this case, the slope is 1.1594. You can see that right in the table. If I interpret it, we would say for each additional semester needed to complete an academic program, the predicted starting salaries increased by about 1,159 euros. If you told me 1.159, it's not in context. If you said 1.159 thousands, which is silly, but it's totally correct, right? Then it's fine. But make sure you're talking about money, right? So put it in the good context.
That's 1.159 thousands of euros.
That's totally fine. Right, because you're not talking about $1 or €1. You're talking about 1,159 euros. That's a fairly big difference, right? So keep in mind the units. When you write it down, just make sure that you said for each additional hour, so that's a unit, or semester, sorry, not hour, semester, you would expect your starting salary to increase by about, you said 1.159.4 or 1.1594. I don't think they would give you full credit for that. I think they would mark that off as like, oh, they didn't really understand the units of the graph. Okay. In order to get credit for these two pieces, you had to do 5 things. Okay. 2 parts for part A and 3 parts for part B. I think most of you probably did these. Okay. Number 1, you had to tell me that it was there was a positive association between the 2 variables. Number 2, you had to say that it supported the newspaper, right? That's why it was a sport. So you had to link those 2 things together.
The scatter plot shows clear association.
Did you say just clear association?
Yes.
No, it has to say positive association.
No, I was like talking about like the newspaper and scatter plot. I did say a positive.
Yes, as long as you said there is an association between those things, and you told me that it was a positive relationship, then you get full credit for part 1. Okay. Part 2 puts together the next 2 sections. Okay, so let's flip the page. An independent researcher received the data for the newspaper, conducted a new analysis by separating the data into 3 groups based on majors of each person. A revised scatter plot identifying the majors of each person is shown below. Right, so now we've actually brought in a categorical variable into the scatter plot. Right, so you can give categories different types of dots. So I'm actually bringing in really a second variable, or third variable, I guess, about these things. Now, the first part says, based on the sample, describe the association between starting salary and the number of semesters for the business majors. What would you say? Okay. For the business majors, there's a strong, linear, negative association between the number of semesters and starting salary. Okay. Strength, direction, form is what I've always told you to do with scatter plot. Now, the question here, do I get credit for not mentioning all 3? We'll come back to that. What you did have to tell me here was that it was a strong negative linear relationship. You had to mention a few of those things, and I'll talk about a little bit in a minute exactly what. But if you said that, that's essentially correct. Okay. Part D, a little bit more specific. Based on those people in the sample, compare the median starting salaries of the 3 majors. What'd you say? What'd you do? So, yes, all the above, what you just said. Okay. It said to compare them. If you simply listed out what each one was, you did not at all answer the question. You would get no credit for simply listing out what they were. Right? You had to describe, you had to compare them, right? Compare, contrast, talk about who's got the most, who's got the least at minimum, right? That's probably what I would have said, right? So-and-so's got the most, so-and-so, there's only 3, so if one's most, one's least, that's implying the other one's in the middle. They didn't have any other options, right? So here's what they said. For part C, they said, for business majors alone, there's a strong negative linear association between the number of semesters and starting salary. Business majors who need a greater number of semesters to complete an academic program tended to have lower starting salaries. Part D, business majors have the lowest median starting salary at around 38,000 euro, followed by the physics at 48,000 euro, and the chemistry majors are the highest median salary starting around 55,000 euro. Let me ask you this. how would you identify, what is your method of identification for the median value? And don't give me the, I eyeballed it. Be more specific with that. You didn't just eyeball it. You know something about the median. You need to find the fourth dot and the fifth dot in the terms of height, the y-axis value, right? And I go right there and I go in between, I go over to my y-axis and I find out approximately what that was. And I mean, when I approximated them, I got exactly what they said here, right? If you were 1,000 off, nothing would have even have been said, right? Not a big deal. As long as you gave a reasonable estimation for that median value, you would have gotten credit for this. Questions? Okay, to get credit for this piece, you had to do yet another 5 things. I don't know why it's 5. In part C, you had to tell me that it was a negative association. Required. Number 2, you had to tell me one or both that it was linear and strong. You didn't have to do both, but you had to state one of them. It was a strong relationship or it was a linear one. As long as you gave me 2 of those, well, if you told me it was negative and then one of the other 2, then you get full credit for this piece, although that's only half the credit.
Why do we have to do all 3?
It was not required. Oh, well, let me back up. On part 1, which was part A and B, if you gave all 5 components that I described, you get a full mark, an E for that piece. If you left one of those things out, okay, and in that case, because it was really only interested in the positive aspect of the association, really this is a moderate relationship. It's a 0.58 R. It didn't really care about how strong the relationship was. Just the fact that does it say the more semester hours, does that indicate more starting salary? In general, the positive nature of the relationship indicates that. I didn't have to go any farther than that. Okay. For part D, I'm sorry. Part C had one more thing. You had to refer to both semester and salary in context of that paragraph. If you left all context out, then you would have missed a piece. Okay, so for part C, negative was required. Context was required. So starting salaries and semesters, right? You had to state those kinds of things. And then you had to state he was either strong or linear or both to get that third element. For part D, you had to state a sentence comparing the 3 majors. You had to explicitly say which was more, which was less, or something to that nature, right? Okay. And in the last part, for part 5, you had to estimate what you thought the median values were. You had to give a numerical value of what you thought those values were estimated to be. And it says as long as it was a reasonable estimate, you get credit for it. Okay. Which would be in between the 2 dots you're looking at, right? Close to those times things. Some of the dots were really close together. Okay. Any questions about this? If you got 5 out of 5 components, you get an E for this section. That's section 2. If you get 3 or 4 of these elements, that gives you a P for this section. If you got less, if you only got 1 or 2 parts of that, then you get an I. You don't get credit for this. Okay. In the last part, back up here. Based on the analysis conducted by the independent researcher, how could the newspaper report be modified to give a better description of the relationship between the number of semesters and the starting salary for the people in the sample? Well, it's asking how could the written description do a better job describing what you see with the 3 majors separated out. How could I write a description to include that would better help the reader to understand the true nature of the data?
Share mine. Can I share mine?
Yes.
They could show the They could show 3 scatter plots for each major separately to demonstrate the negative correlation with numbers of semesters taken and starting annual salary.
Okay, that is part of it. I don't need to draw another scatter plot because I can see it clearly right there. Okay, I don't need to do another graph, but I definitely need to include that the relationship within a major is negative. Meaning, if I'm a business major and it takes me forever to get my degree, I'm probably not going to get the best job. I'm probably not the best businessman out there. If it takes me forever to get my physics or my chemistry degree, I probably wasn't the best physics student. I'm probably not going to get the best, highest paying job out there, right? That makes sense, right? Or maybe I'm lazy and it just takes me forever. So people look at it like, oh, it took you 7 years to get your 4-year degree. What's going on, right? That might not, I mean, I'm just supposing, but that's part of it. What else should I kind of include? There's 2 aspects I need to make sure I discuss here, because the original statement wasn't wrong what the newspaper said. It's just more complex than just the longer you go to school, the more money you make.
Yeah, the fact that major CC play a bigger part in semester time.
Generally speaking, if you get a chemistry degree, you will make more money than if you got a business degree, right? So the major does play an aspect of, well, the harder the degree is, generally speaking, the more money you will have in your starting salary. Here's what they said. The newspaper should report a modified account to account for major. Overall, majors that take longer to complete tend to have higher salaries, aka, if you get a chemistry degree, you'll have the highest of the 3 starting salaries. Even though it takes you longer to complete a chemistry degree, you're going to be making more money than someone who had a physics or a business degree, that kind of thing. However, within the major, students who take greater number of semester hours tend to have lower starting salaries compared to all the other of the same type of majors, right? To get full credit for Part E, and it's all by itself, okay, you had to state that there was a negative association within the majors, and you had to state that the overall scenario was a positive association. Okay, noting that if you got a chemistry degree, which takes longer, you will get a higher salary no matter what, how many semesters you go. If you only stated one of those 2 things, you said, oh, they need to add that within the majors it's a negative association. If you only said that, then that would be a P. Okay. Now, in order to score, any questions before we go on? So you got 3 sections. Parts A and B are one section. You should have given yourself an E, a P, or an I. And then you had the second section, which was parts D and E, C and D, and the third section was E. Here you have, if you got all 3 sections essentially correct, that would be a 4. Okay, that would be 4 times 3.125. That's a pretty substantial amount of points. That's 4.5 points. That's 12.5 points. Okay, 12.5. That's a third of the points you needed to get to a 3. Okay, now I don't know I've ever seen a 4 on a number 6. They're probably going to nitpick you somewhere and pick off something. But if you missed one part, specifically, if you got 2 E's and a P, that's a 3. That's really good. Okay, if you got 1 and 2 parts partially correct, and part 3 essentially correct, so that's 2 P's and an E, but it's part 3 that was essentially correct, then you can also still get a 3. If you got 1 and 3 essentially correct, but 2 was totally wrong, you still get a 3. Okay, part 3 was considered much more complicated. You get more points for it. Okay, 2 and 3 were E's, and 1 was an I. You still get a 3. And of course, less than that, you'd probably get a 2. If you only got 1 section right, or 2 P's, that would be a 1. Okay, that took longer than I wanted to, but that is worth going over. Hopefully that makes a little bit more sense. I recorded this so you guys can watch it later if you need to kind of go over it. But